Hi, and welcome to another in our series of short demonstrations of new features that have been added to MachineWorks in the MachineWorks 8 releases. Just a reminder that MachineWorks is only available as a software library. If you're interested in a ready-to-use end-user product, please contact one of our customers. There's a selection of logos on the website www.machineworks.com. One important reason for creating a virtual in-process stock using material removal simulation is to detect gouges and rest material. A gouge is where the CAM toolpath removes too much material, and rest material is stock material remaining when the toolpath hasn't removed enough. Analyzing rest material is an important process when optimizing toolpaths for reducing cutting time. MachineWorks has several different ways to analyze these conditions. Users are most commonly shown a heat map based on points sampled across the surface of the in-process stock. At each point, the nearest distance to the design part is calculated, and this is displayed as colors on the stock surface. For more accurate in-depth analysis, it can be useful to use MachineWorks' unique polygonal BREP Boolean engine to create watertight solids of the gouge and rest material by subtracting the in-process stock from the design part and vice versa. So in this short demo, we'll show you both of these methods and also how licensees of MachineWorks can now use Polygonica's offsetting to reduce noise and produce a cleaner result when creating solids of gouges and rest material. So here I've fired up MWMC Demo, which is the MachineWorks developer's internal test tool, and it's currently displaying an initial cuboid stock in blue. You can now see the design part in red. So this is the shape the cutting path is trying to create, and it's this model that will also be used in the comparisons with the in-process stock. So first, when we run the simulation, I'm showing you on-the-fly gouge detection. So in this case, MachineWorks is calculating the gouges and undercuts live after each material removal step as it's doing the simulation. So you can see the standard heat map colors. Green represents intolerance regions, while stronger blues represent thicker areas of rest material, and yellows through to red represent deeper areas of gouges. As you can see, there's clearly a big gouge on the sides, and this was a test part designed to demonstrate gouge detection. And there you've got a very nice result. You can also see that the rest material that you'd expect to see with a cutter of this radius on this type of part. So now we'll compute the actual solid bodies of rest material by doing a 3D Boolean subtraction of the design part model from the in-process stock model. And there you can see the result. And so this is a true closed watertight solid model of the rest material. But you can see there's quite a lot of very thin material. The MachineWorks Boolean works at extremely tight tolerances, which gives a lot of advantages, but that also means that some of this material might be there in real life, but it could be the result of slight floating point variations in both the design part and in the toolpath. And even if it is there in real life, it could easily be within an acceptable tolerance, and so it would be useful to have a way to filter it out. And that's where Polygonica's offsetting comes in. So if I double click again, this time when MachineWorks will call the Polygonica libraries to offset the design part outwards by a small amount, in this case 1/1000th of an inch. And then when MachineWorks redoes the Boolean subtraction, we'll see that a lot of noise has been filtered out, and we're left with the thicker regions of solid material. And there you have a much nicer, cleaner result suitable for analysis. And of course we can go further, so I'll now use 4 1/1000ths of an inch, and we'll see only the really thick regions of material remaining. And as said before, this is pretty much what you'd expect to see with this type of cutter on this type of part. And just finally, here's a display of the design part and the rest material solid both together in the same display, so you can inspect them together, and we could make one transparent, etc., etc. So that's Polygonica's offsetting used to filter noise from different solids in MachineWorks. The clean, noise-free solids of remaining material are ideal for input and analysis for advanced rest machining algorithms. This new functionality from Polygonica is available to existing MachineWorks customers to drop into their builds for no extra license fees. Just contact us and we'll get the paperwork sorted. For any others who are interested in learning more, please don't hesitate to contact us through the forms on the website www.machineworks.com. Many thanks for your time and for listening.